Okay, so today we're going to be doing 6.2, solving exponential equations using properties of exponents. And the goal is for all of you to be able to solve exponential equations using exponent properties. So what that means is we're going to be writing and solving like equivalent exponent equations, which might seem a little weird, but basically what we're going to be working on is we're going to be dealing with these bases. And so when the bases are the same, like here, then the exponents must be the same. So what that means is if x to the a equals x to the b, then a equals b. So the whole goal is to get these bases to look the same. So whenever we see an equation, like in example 1 or problem 1, whenever we see an equation, we're trying to get these bases to be the same. So for example, in example 1, we want both these bases to kind of look like a 2. And as a little hint, you always want to go for the things that are like, you can't reduce it anymore basically. So 2, 3, 5, 7s, or your prime numbers. So let's go ahead and zoom in here. Let's do example 1 together. So like I said, we're going to be trying to get this 64 to be a 2. Okay, so you could do this in your calculator, but what I like to do is I like to go like, oh, 64 equals 8 times 8. I know that 8 equals 2 to the third, which means that 64 equals 2 to the third times 2 to the third. And remember, we can add exponents, so we talked about that last time. But when we have exponents being multiplied together like here, then that means we can add the exponents, right? Since the bases are the same. That was talked about in the previous notes. So what that means is I can actually say 64 equals 2 to the 6, because 3 plus 3 equals 6. And so we have 64 equals 2 to the 6, which means that back over here, so I'm going to do this in a different color. Back over here, I could write that as 2, 3x minus 7 equals 2 to the 6th to the x. And putting in those parentheses is really important, right? Because remember, we have that rule that says when we have exponent and then an exponent on the outside of parentheses, we multiply them together. So we don't add them like we do over here. We multiply them, because this is kind of like saying 2 to the 6 times 2 to the 6 times 2 to the 6 times 2 to the 6, blah, 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 x number of times. And so then we can rewrite this as 2, 3 to the x minus 7 equals 2 to the 6x. And so now you see that we have these bases, and that's what we were wanting. So you have these 2's at the bottom. And so using our rule that we just talked about, that if the bases are the same, then the exponents are equal, we can actually rewrite this as 3x minus 7 equals 6x. And then it's just a matter of solving it algebraically. So we subtract 3x from this side here, and then we get negative 7 equals 3x divided by the 3. We get negative 7 divided by 3 equals x. And that is our answer. Okay, so now I'm going to have you guys working on problem number 1 by yourself, but first I want to help you get started. And so because this can seem a little tricky, right? So you might recognize that 27 equals 3 cubed, right? Because 3 times 3 is 9, times 3 is 27. So you might see that, right? But we have this 1 over 27. So we have 1 over 27. Again, we talked about that last time, but we need to write it with an exponent that's a negative, right? Because negative exponents are actually reciprocals. So to get 1 over 27, we kind of need to write this as like 3 to the negative 3. Because when we have this negative, we could also think of it as like 3 to the 3 to the negative 1, which would make it the reciprocal. So 1 over 3 to the third. And that's where we get our 27. So we can actually rewrite this equation. I'm going to go back to blue as 3, 5x plus 4 equals 3 to the negative 3 times x minus 2. So now I want you to go ahead and pause the video and see if you can finish solving this one by yourself. Again, remember, we're trying to get common bases, so we're trying to get just the 3 and just the 3, and then everything else up in the exponent form. Okay, so go ahead and pause the video and try it by yourself. Okay, so the first thing I did is I first multiplied this -3 out because I distributed it right, and we talked about this before. Once inside the parentheses, then it multiplies out. So -3 times x is -3x, -3 times -2 is +6. And so now we have these bases are the same, which is what we are going for. So I can say 5x plus 4 equals -3 plus 6, which is what I have here, right? And then I'm trying to get the x's on one side and the numbers on the other. So I subtracted 4 over here, subtracted 4 on this side, added 3x on this side, added 3x on this side. You might have done those in 2 separate steps, and that's okay, but we end up with 8x equals 2. Divide out by 8 to get the 1x, and we have x equals 1/4. So hopefully that's what you got, but if you didn't, that's okay too. Just go ahead and look that back over. Now we're going to go ahead and do another example. So this one's a little bit more complicated, right? Like there's multiple values. So we have these 2 terms on this side and 1 term. But remember, our rule asks us for 1 term on this side, which means we need to simplify this out to make it just 1 term. So like 1x to some value, or some variable to 1 value. So you may or may not see this, but again, you might want to just try it with your calculator. But I know from before, from our previous problem, that 3 to the 3rd equals 27, and then 27 times 3 equals 81, which means 3 to the 4th equals 81. So we have 2 81s, right? We have an 81 here, and we have an 81 here. So I could rewrite both of those as 8x minus 4 times 3 to the 4th times 2x minus 8 equals 3 to the 4th to the 9x plus 1. And so again, then we're just going to go through and simplify. So I'm going to multiply these terms out. So we're going to multiply this 4 out into this 2x minus 8 and this 4 into the 9x plus 1. And so that's going to go ahead and give us 8x minus 4 times 3 and 2 times 4 is 8. X 4 times 8 is -32. Well, 4 times -8 is -32. And then 4 times 9, so we have 3 to the 36. X 4 times 1 is 4. Okay, so we're almost there, but again, we have these 2 terms that are multiplied, but they have the same base. They're both 3. And so from our rules, we still know that we can add these exponents. So again, I could rewrite this as 3. I'm going to put it in parentheses just to make it a little bit more clear. Plus 8x minus 32. So see how I added in these exponents and this set of exponents together. So that's what my goal is. Again, that equals 3 to the 36x plus 4. And I know it might seem weird to keep rewriting the equation, but it's really good to make sure you keep your steps. And so 8x plus 8x is 16x. We have 16x, and then -4 minus 32 is minus 36. And that equals 3 to the 36x plus 4. So now we have our same bases, which is that goal that we were trying to get to this whole time. And I just realized my 4 is really low, so we're going to go ahead and move that back up to make it a little bit more clear. Plus 4, that's an exponent term. Okay, so now, again, we can go back and we can set the exponents equal to each other because we have the same bases. So we have 16x minus 36 equals 36x plus 4. And then again, just some basic algebra. So we're going to subtract 16x from this side, from the other side, subtract the 4 from this side, and the 4 from this side. And -36 minus 4 is -40. 36x minus 16x is 20x. Divide out by 20, divide out by 20. We have x equals -2. So 8x, or x equals -2. Sorry about that, I wrote this really poorly, so we're going to rewrite that to make it nice and pretty. X equals -2. Okay, and so now we're going to go on, but again, just dividing up by 20, so it's just basic algebra at that point. Okay, so now we're going to go on, and again, this one's a little bit complicated, so we're going to simplify this out together, but first, let's notice that we can write 16 as 2 to the 4th, and that's just because, you know, 2 times 2 times 2 times 2 equals 16. So then we can actually rewrite this equation as 2 to the 4th x plus 5 over 2 to the 7x plus 2 equals 2x minus 2. Sorry about that, minus 2. Okay, so I'm going to go ahead and let you try and solve the rest of this on your own, but just remember that this is in the denominator, right? So we need to flip this back up because we need this all to be one simplified term. And so to do that, you need to take a negative exponent. So go ahead and pause the video, see if you can get to this next part on your own. Okay, so you could have taken this as a negative exponent like I talked about, or you might have just remembered that rule for when we're dividing exponents with a common base from the previous one, or we can actually just subtract them. But this actually just comes from the idea that you can take a negative here, distribute that out, do the multiple. But in either case, you should have gotten the same thing of 2 to the negative 3x plus 18, and that was just from, simplifying this to 2x minus 2. And then we have the same bases. So over here in the green, like I've been doing the whole time, I just went and solved for my x. So I set the two equations equal to each other, did some algebra down here, and then ended with x equals 5. So go ahead and look that back over if you didn't get that same thing, but you might have been able to do a little bit more steps or skip a couple steps, and that's okay. Okay, but sometimes, so I'm going to go ahead and read this. Sometimes you'll need to change both bases. You'll need to change both bases to get a common base. So see, in this one, we have a 1 over 64 and a 1 over 16, and neither of these are kind of our simplified versions. So from before, we already know that 64 equals 2 to the 6th, and we know that 16 equals 2 to the 4th. But if you didn't remember that, or you hadn't just solved ones that had done that, again, you could just figure that out in calculator or just kind of multiply it out. So our goal was to have these common bases, so now we do with these 2's. So we can rewrite this expression up at the top. So we can rewrite this whole equation as 1 over 2 to the 6th, negative 2x plus 4, equals 1 over 2 to the 4th, 5x plus 2. And you might have actually seen that we could rewrite 1 over 64 as 2 to the negative 6th, and 1 over 16 as 2 to the negative 4th, because again, we're just taking the reciprocal of it, right? Because that's how we flip the terms up and down over the fraction. So that means we can actually rewrite this as 2 to the negative 6, it's negative 2x plus 4, equals 2 to the negative 4 to the 5x plus 2. And then again, we need to distribute out this negative 6 into the negative 2 plus 4, and the negative 4 into the x plus 5. So when we distribute that out, we get 2 negative 6 times negative 2x is 12x. Negative 6 times positive 4 is negative 24, equals 2. Negative 4 times 5 is negative 20x. Negative 4 times 2 is negative 8. And so now we have those common bases that we were trying to do the whole time. And so we can actually just go ahead and solve for the x value now. So 12x minus 24 equals negative 20x minus 8. And then just some more basic algebra. So we're going to add 8 on this side, subtract 12x on this side. So then these cancel, these cancel. So we have negative 24 plus 8 is negative 16. Negative 20 minus 12. X is negative 32x. Divide out by negative 32. Divided by negative 32 and get x equals 1/2. Okay, so now, again, same kind of thing, right? First we need to get these common bases. So we need to get these to look like something common. And I'm going to go ahead and let you guys try to figure this one out entirely on your own. But again, note they're not the common bases and we need to do that. So go ahead and pause the video at this point and then unpause when you're ready to check your answer. Okay, so hopefully you saw that 8 can be rewritten as 2 to the third, and 4 can be written as 2 squared, and so we're getting that common 2 value as our base. So then rewriting this equation, we have 2 to the third to the 3x minus 7 equals 2 to the second times 6x minus 1. And so then distributing out this 3 and distributing out this 2, we get 2, so our common base, to the 9x minus 21 equals 2, our common base, to the 12x minus 2. So now that we have these common bases, we can go ahead and just solve for our x value. So we can say 9x minus 21 equals 12x minus 2 because of our common base rule. And then just doing some algebra, we end up with x equals negative 19 divided by 3, which is not a pretty answer, but I promise it's the correct answer. So if you got this far, great, good job. This is just some more practice using the rules of exponents, because we're next going to be working on exponential functions, and knowing how to do all of this kind of simplification is really going to help for that part. So yeah, just remember to answer the question at the end. I don't think there's a summary for this section, but just go ahead and make sure you either make your own math question or ask a question if you don't understand something.